Welcome to the online platform of Concepts of Geology. We were doing a live session on structural geology practical problems. In this session, we will learn about the interpretation of geological maps and we will learn the numerical problems of the subject structural geology. Okay. Although this should be a live session and this type of practical problem should be learned in a properly interactive manner, but we will upload some recorded versions of the classes in this online platform. If you want to join the live classes, please let me know through the registered email ID of the channel, or you may write on the comment section also. So on the last class, that was the second class, we learnt about the calculation of attitudes of planes, that means measuring of strike and dip direction through 3-point problems in a flat topography. Okay, and on today's class we will learn to find out the attitudes of planes by means of 3-point problems, but now the topography will be uneven. Okay, but before starting today's class, I will clarify the problem that was given on the last class. Okay, the problem was 3 boreholes ABC were drilled on a flat surface and they encountered a coal seam at 200 meter, 1200 meter and 700 meter depth respectively. The forebearing of A to B was 330 degree and the distance between them was 1000 meter, and the back bearing of B from C was 15 degree and the distance between them was 700 meter. Okay, so I need to draw a plan of this borehole location in 1:10,000 scale. That means 1 centimeter in my drawing will be 100 meter in the actual ground. Okay, then I have to find out the attitude of the coal seam. We will try to answer these 2 questions first and then we will move on 3rd and 4th question. The procedure to solve this kind of problem is, first we have to mark a north arrow in my map. Okay, so this is the north marking and I have to write out the scale. The scale is 1 centimeter equal to 100 meter. Fine. So after fixing the scale and the north arrow, I will draw the triangle. Okay, I will plot the 3 boreholes in my map. Okay, so first I will take the point A arbitrarily anywhere in the map. Okay, suppose I have placed the A point here. Okay, so it is the point where my A borehole is located. Fine. So after the location of A, I have to fix out the location of the B. So the relationship between A and B is a forebearing is taken from A towards B and the value of the bearing is 330 degree. Okay, so I will make an angle 330 degree like this. Okay, and I will draw a straight line along this angle. Okay, so that means in this straight line somewhere the B will be placed. To know the exact location of the B, I need to know the distance between A and B. The distance is said 1000 meter means, according to my map scale, that will be 10 centimeter. So I will measure 10 centimeter along this line. Okay, and I will find out the position of B. So suppose this length is 10 centimeter and the position of B is here. Okay, so now I have placed the A and B on the map. After that I need to plot out the C. Okay, the 3rd borehole. It was said that a back bearing is taken at B and it was taken from C. Okay, so that means I am measuring the angle in this direction now. Okay, but whenever we are taking a back bearing, the precondition is from where I am taking the back bearing, that position should be known. That means the precondition should be the C should be located first. Rather, the location of B is known here. Okay, so that means I need to convert this back bearing value into forebearing value. Okay, and the relationship between back bearing and forebearing is they have a difference of 180 degree. Okay, so that means if I am taking back bearing from C and it is 15 degree, then if I take the forebearing from B towards C, that will be 15 plus 180 degree. That means 195 degree will be my forebearing from B towards C. Okay, so now I am measuring this angle in this direction. Okay, so I will take my protractor here and I will measure a 195 degree angle here and I will draw a straight line along this 195 degree value. Okay, and in this line somewhere will be the position of the point C. Okay, the borehole point C. Now the distance is given between B and C is 700 meter. So I will take 7 centimeter length of this line and I can find out the position of C here. Suppose the C is coming here. Okay, so up to this much I have completed the answer of the first question. That means we have plotted the borehole locations in 1:10,000 scale in my map. Then the second question was to find out the attitude of this coal seam. Okay, For doing that, we need to know the depth of the three boreholes A, B and C. Okay, A was 200 meter depth, B was 1200 meter depth and C was having a depth of 700 meter. Okay, so that means at this point of A, I will have a stratum contour of 200 meter. Okay, here I will have the stratum contour of 1200 meter, and here the 700 meter stratum contour will be passing. But I need to remember that all values will be negative because all the boreholes are going into depth with respect to the datum. The problem is given in a flat topography, and this topography I am taking is the datum plane. So whenever I am going in depth with respect to this datum plane, I am going into the negative value. Now to find out the strike lines, I have to graduate this arm of the triangle. Okay, why I am choosing this arm? Because in this arm I am having the maximum and minimum depth value of the boreholes. Okay, they are 200 meter and 1200 meter. So in between 200 and 1200 we will definitely have the 700 value somewhere. Okay, I need to find out the point where the 700 meter value will be, and after that I will join these 2 points to find out the stratum contour of minus 700 meter value. Now I have an easy process to find out this. This point is having a value of 1200 and this point is having a value of 200. So that means if I take the arithmetic mean of these 2 points, so that will be 1200 plus 200 divided by 2. That means 1400 divided by 2 means 700. Midpoint of this AB line will be the value of 700 meter. Okay, this is a special case. The problem will be not so easy each and every time. Okay, but for now I can find out the midpoint as the 700 meter strike line point. Okay, so I will join this point and this midpoint. Okay, because this was the location of C, and the C is having already a depth of 700 meter. The C has encountered the coal seam at 700 meter already, and I am having the 700 meter depth at this midpoint now. So I will join these two 700 meter points to get the 700 meter contour line. Okay, so this will be definitely a stratum contour, and this is also a map strike line, and this is having a value of minus 700 meter. So whenever I am getting this minus 700 meter strike line, I can have the minus 1200 meter strike line also. All these strike line will be parallel to each other. Okay, so I will draw a line which will pass through this point, this B point. Okay, and this will be parallel with this line. Okay, so that will be what? That will be the strike line of minus 1200 value. Again on this point A, I can draw a parallel line which will be the minus 200 meter contour line or minus 200 meter map strike line. Okay, so by this I can draw all the strike lines. All the strike lines will be parallel. I can make graduations furthermore to find out the intermediate contour lines. After that I will measure the orientation of these contour lines with respect to the north. So this was the orientation of north in this area. So I will take my protractor out and I will measure this angle. Okay, to find out the orientation of the contour line on this end. Okay, so after having this end orientation, I will have the orientation on this end also. Okay, how? This end will have a 180 degree difference. Okay, you construct this diagram in your copy and you will find that this angle will be 60 degree and this angle will be 240 degree. So the strike of this coal seam is 60 degree by 240 degree. Here I am having the borehole A which is encountering the coal seam at 200 meter depth, and here it is 1200 meter depth. So definitely the coal seam is sloping on this direction. Okay, to find out the true dip direction, I will draw a perpendicular line with the strike. Okay, so this was my strike. I will draw a perpendicular line. This is the dip direction. What will be the value of dip direction? You can measure it, or you can say it will be perpendicular to the strike line. So if this end is 240 degree, then the dip direction will be 240 degree plus 90 degree, that means 330 degree. Okay, so that means the bed is dipping towards 330 degree towards the northwest. Okay, now to find out the amount of dip, I need to measure the spacing between two contours. Suppose I am taking the spacing between these two contours, 700 meter and 500 meter. All the values are in negative. When you will draw the construction in your copy, you will find that this spacing is 2 centimeter. So I will draw a 2 centimeter horizontal line. Okay, suppose this one. And what is the vertical fall between the contours? This is 200 meter. Okay, between 500 meter and 700 meter. So according to my map scale, this will be 2 centimeter line. Okay, the vertical line will be 2 centimeter. Construct the triangle like this one. Okay, and I can measure this angle to find out the amount of true dip. Okay, so this is 2 centimeter and this is 2 centimeter, means this angle will be 45 degree. Okay, So that means the dip value is 45 degree and the bed is dipping towards 330 degree towards northwest. Okay, so this is the attitude of the coal seam. Okay, now as this was a special case, we have found the 700 meter contour line very easily, but for doing that in a perfect way we need to do it by this geometric method. Okay, I have to draw the AB line first, like this one. Okay, this is the AB line. Here I will draw the 200 meter borehole, that means 2 centimeter according to my map scale. Here I will draw the 1200 meter borehole, that means a 12 centimeter line need to be drawn. Okay, I will join these 2 points because both these boreholes have encountered the coal seam. So this will be the appearance of the coal seam along AB profile. So for find out the 700 meter borehole, I need to draw a 700 meter line here, that means 7 centimeter according to my map scale. I will copy this line with my divider. Okay, and I will place the divider in this construction to find out where the 7 centimeter line is fitting. Okay, suppose it is fitted here. Okay, I need to do a hit and trial method to find out where the 700 meter is exactly fitted. So suppose this line is fitted here, then I will measure this length, okay, with my ruler, or better is to copy this length with the help of this divider again. Okay, and I am measuring this length from this A end. Okay, so after that we will go to the triangle again and we will place one end of this divider at A point, and I will try to find out where the 700 meter borehole point will come, and I will join the 2 points to get the 700 meter strike line. Okay, so we have answered the first and second question. The third question was, at which distance on due south of C the coal seam will outcrop. Okay, so whenever we are drawing the map strike line or the stratum contours, we know that the 0 meter line is drawn on the surface. So 0 meter line means here I need a borehole which will have a 0 meter depth, and this will encounter the coal seam. That means what? That means the coal seam is already on the surface. So if this is my 200 meter strike line, I will find out the 100 meter and 0 meter strike line. All the strike lines will be same spacing and they are parallel to each other. Okay, so suppose this is the 0 meter strike line here, and I will move due south of C to find out where I am touching the 0 meter strike line. I will measure this distance with my ruler. Okay, and I will convert it in my map scale. Suppose this is 8 centimeter, so according to my map scale it will be 800 meter in the real ground. So that means in due south of C I will have to move 800 meter to find out the outcrop. Okay, then the next question is, a new borehole D is drilled 600 meter away and 25 degree east of A. So suppose I have drawn the 25 degree east of A here it is, and the distance is 600 meters. So that means the length will be 6 centimeter. Suppose I have reached here on this point. Okay, so then I will find out what is the contour value at this point. Okay, so clearly I am in the midpoint of 500 and 600 meter contour line. Okay, so that means I am at almost 550 meter contour line. This is a stratum contour. That means what? If I do a borehole at this point, I will encounter the coal seam at 550 meter depth. Okay, so this one is the solution of the problem which was given on the last day. Okay, the problem was given on a flat topography and we have solved it through 3-point problem method. Okay, now we'll start the topic allotted for today. Okay, this was the 3-point problem on uneven topography. So up to that, whatever we have done in the flat topography, but today my topography is not flat. Suppose I have a hill here or suppose a valley here. Okay, so this is called an uneven topography. Let's learn how to solve out the 3-point problem in such kind of uneven or undulatory topography. Okay, now suppose this is my topography, this is undulatory, this is my target bed. Okay, I am doing boreholes at C point, B point and A point. The depth of the borehole at point C is 500 meter, here it is 300 meter and here it is 600 meter. Okay, and the elevation of the point C from this datum plane, this is mean sea level, the elevation for point C is 900 meter, here the elevation is 500 meter and here this elevation is 550 meter. Okay, these elevations are called reduced level or RL. So the data we are having now are the RL value of this point C and the depth of the borehole. By using these data we will find out the attitude of this target bed. Okay, but the problem here is the depth value of the borehole is a variable factor because I am measuring the borehole depth from this topography and the topography here itself a variable factor. Okay, the topography is not flat, the topography is varying with respect to the datum plane, that means my mean sea level. Okay. So when we will solve the 3-point problem by these data, we cannot use this data, I mean the depth data, because the depth data is a variable factor. So what we should do is we have to convert the depth data into some kind of value which will not be variable. So that means instead of measuring the depth, we can measure this elevation. Okay, this elevation will not be variable because this elevation will be measured with respect to this mean sea level, and the mean sea level is a static factor. Okay, so we will convert this value, I mean this depth value, which was measured in terms of this topography, that will be converted into this elevation value, which will be measured with respect to the mean sea level. So for doing that, I need this value. Okay, so if this is the total is the 900 meter and this is 500 meter, so definitely this will 900 meter subtracted 500 meter, so this will be 400 meter. Okay, this is called the reduced level for this point. Okay, where the borehole is intersecting the target bed. Okay, so when I will do these calculations for this all the 3 boreholes, I will have the reduced level of the coal seam here at 400 meter. So that means this length is 400 meter. Here this length will be 200 meter, 500 meter minus 300 meter. Okay, and here the reduced level of the coal seam will be minus. Why? Because here the depth of the borehole is 600 meter and the RL is 550 meter. Okay, so when we will find out the reduced level of the coal seam, that means when I will subtract the depth value from the elevation value of this topography, this will be negative. Why this is becoming negative? Because see here the coal seam is going beyond the mean sea level. Okay, it is laying here below the mean sea level. Okay, so that means wherever I am getting the reduced level in minus value, that means I am moving below the datum plane. Okay, so what should be kept in mind, that reduced level of the target bed is equal to elevation or RL of the borehole collar, that means the top of the borehole, that means the topography. Okay, and the depth of the borehole. Okay, so that means the elevation of the topography minus the depth of the borehole will be the reduced level for the target bed. Now when the reduced level will be positive, that means the bed is above MSL. Okay, that means the value is elevation, the value will be positive, and when the reduced level will be negative, that means the bed is going below the datum plane, below the MSL. So with respect to MSL, this is in depth, not in elevation, rather this is in depth, so this value will be negative. Now remember, when we have done the problem in flat topography, we have used the concept of RL but unknowingly. Okay, this was the datum plane in case of a flat topography. So whenever it is datum plane, that means it has a elevation value of 0 meter. Okay, so this is 0 value, and whenever I am going into depth, suppose this is 2000 meter value, so that means the RL at this point of the coal seam will be 0 minus 2000, that means minus 2000 meter. Okay, I was continuously saying on the previous class that all the values will be negative. I think you have understood the importance now. Okay, now coming to the previous example, suppose this is the MSL. Okay, this line is the MSL. So when it is the MSL, I had the borehole point A here. Okay, and this value is minus 50. Okay, according to my map scale, suppose this value is minus 50. So that means it will be in depth with respect to the MSL, with respect to the datum plane. And after that, I was having the C borehole here, and here the RL of the coal seam was positive 400 meter. Okay, so that means it will be at elevation with respect to the MSL. So I am drawing the 400 meter line here. Okay, suppose this is 4 centimeter according to my map scale. Now I have a third borehole. Okay, the B borehole, which is having RL value of the coal seam positive 200 meter. Okay, so that means in between this A point and C point, I will have that value somewhere. Okay, so to find out the borehole, I need to draw a horizontal line of 2 centimeter. Why? Because according to my map scale, 2 centimeter is equal to 200 meter. So I have drawn the 2 centimeter horizontal line. I will take the divider, I will copy the line, and I will try to fit this divider in this diagram, in this construction by hit and trial method. Suppose the divider is exactly fitted here. Okay, that means this point is the point where I will get the borehole B. Okay, so I will measure this length. I am measuring from which end? I am measuring from point A. Okay, keep it into your mind. Now let us construct the triangle and try to find out the strike line. Suppose in the map view, the position of A, B and C is located like here. Okay, so this is the AC line. Okay, and here I have got the target sim RL minus 50, and here it is positive 400. So in between them somewhere will be the 200 value. The distance I have copied by means of divider, so I will put one end of the divider here, and I will try to find out where the another end will pointing. Suppose it is pointing here, so that means this is the point where I will get the 200 meter RL value for the coal seam. So if I join this 200 and this 200 with a line, this will be the 200 meter map strike line or 200 meter stratum contour. Okay, whenever I am getting this 200 meter stratum contour, I can draw the 400 meter stratum contour. Okay, this will move through this point C, and all the strike lines will be parallel. I can draw the minus 50 meter strike line also. This will move through point A, and it will also be parallel. So now we have got the orientation of the strike. We can measure the strike with respect to north also. Now which will be the direction of dip? The dip direction will be always from higher value to lower value. Which is higher value here? Definitely 400. So the dip direction will be from 400 to minus 50. Okay, and if I am talking about the true dip, this will be perpendicular to the strike direction. Okay, so this is the dip direction. Now this kind of problem, I mean the 3-point problem in uneven topography, may be represented by this type of diagrams. Okay, this is a map diagram. Here the point A, B and C has already been plotted, and we are giving two values here. Okay, which value is depicting which one, that is written clearly on the index. Suppose the black value is the elevation and the red value is the borehole depth. Okay, so don't confuse why there are two values. One value is the elevation of the topography and the other value is the borehole depth. I have to find out the RL of the target bed. How can I find out this? I have to subtract the borehole depth from the elevation. So accordingly you find out the RL values. Okay, and then construct the triangle, then find out which arm you should graduate and find out the strike lines. Okay, so I think you have understood how to solve the 3-point problem on uneven topography. You have to find out the RL values for the target seam first, then you construct the triangle, and then the ordinary process which we have done at the last class. So here also 3 boreholes are given, A, B and C. You plot their location according to the instruction given. Okay, one thing you may feel confusion here, that is the direction mentioned. It is written south 15 west. That means what? 15 degree west of south. Remember this, south 15 west means 15 degree west of south. Okay, north 15 west means 15 degree west of north. Okay, these are called quadrant bearing system. Okay, south 15 degree west means, suppose this is my cross. Okay, this is the south direction, and I need to find out the 15 degree west of south. So this will be west. 15 degree west of south means this angle I need to find out the 15 degree. Okay, so ultimately in whole system bearing or in azimuth bearing, the value will be 180 plus this 15, that means 195 degree. Okay, so as the instructions are given, you try to construct the triangle. You will choose which arm you need to graduate, then draw the strike lines, find out the dip direction, find out the attitude of the bed. So you can easily solve these first 4 questions, but this 5 and 6 question is new for this class. I will not provide any hint about these last 2 questions. You try first, then on the next class we will have a discussion on these questions also. Okay, if you are having any queries till now, you may contact me through the registered email ID, or you may mention on the comment section. Okay, so goodbye and thank you for watching.